Hello everyone. So let's now solve practice and in week 6 question number 2. Consider the following set. In column A, the matrix representation of some linear transformation are given with respect to standard order basis. Match the entries in column A with the set TS given in the column B and the geometric representation of S and TS in column C. So first we can clearly see that as S is the set of all the elements such that x plus y is equal to 1. We know that the line x plus y is equal to 0 looks like this. So this is the line for x plus y is equal to 0. So x plus y is equal to 1 would be the scaled version of this. So that would look like some this. So this is the line for x plus y is equal to 1, and that is pretty much same in everywhere in third column. Now we have to find the image of the each linear transformation given in column A first. Okay, so let's start with first. So this is our linear transformation, and this is the matrix representation of this linear transformation with standard ordered basis for both domain and codomain. So our transformation is from R2 to R2 with its matrix representation 1 minus 1 minus 1 and so we are taking standard order basis for domain and codomain. So this is our basis for R2, and our image vector would be some linear combination of the column of this matrix representation. So that would be 1 times and here minus 1 times. And here would come the basis vector for the domain from which this matrix representation is given. And as this matrix representation is given with standard order basis, so here will come the 1 0 and 0 1. So this would be 1 minus 1. And similarly here it would be so we can write any xy as some linear combination of x times 1 comma 0 plus y times 0 comma 1, taking t both sides and using the property of linear transformation, and we have already found t of 1 0 and t of 0 1 as these values. So it would be x minus y minus x plus y. So this would be our linear transformation. Now our goal is to find the image of the linear transformation with respect to given set S. So again, our set S is the set of all xy such that x plus y is equal to 1 and xy are real numbers. So that means these are basically the set of x and 1 minus x. So we have to check with t of x and 1 minus x. So given the definition of our linear transformation, we will plug in these values where our x is just x and y value is 1 minus x. So let's plug these values. So x minus 1 minus x, comma, minus x plus 1 minus x. So this would get us 2x minus 1, comma, minus 2x plus 1. Now let's represent these as some x dash, comma, y dash. So our x dash is equal to 2x minus 1 and our y dash is equal to minus 2x plus 1. Now notice that if we add these two quantities, we will get 0. That is, x dash plus y dash is equal to 0. Hence, our T of S is the set of all xy such that x plus y is equal to 0. And our xy belongs to R. So, the image of the set S with respect to this linear transformation would be a line passing through the origin such that x plus y is equal to 0. And as discussed before, the graphical representation of this line would look something like this. Now, similarly, we will check for the other two linear transformation as well. For second linear transformation is, it is also from R2 to R2, and the matrix representation is 0, minus 1, 1, minus 1. Now I will directly write the images of these vectors. To get these images, we will do the same process as we did before. So transformation would be minus y comma x minus y. So this is our transformation, and our set as same as before. Now this is x comma 1 minus x. Okay, so we have to plug this set values here, x comma 1 minus x. So with respect to this transformation, we have find these values. So this would be minus 1 plus x comma 2x minus 1. So again, we will consider this as x dash and y dash. X dash, and this is y dash. So x dash equal to minus 1 plus x, and y dash is equal to 2x minus 1. Now, if we do the 2 times of this, that is 2x dash, this would be equal to minus 2 plus 2x. And notice now that, for if we separate these two quantities, that is 2x dash minus y dash, so that would be minus 2 plus 2x minus 2x plus 1, we will get minus 1. So that means T of S is set of all elements x comma y such that 2x minus y is equal to minus 1. So that x comma y belongs to real number. So what we did basically here is, first we find the images of our set S with the given linear transformation. Then we are finding the relation between x and y component in the given vector, like what is their relation, so that we can find the line with respect to that. So the line that we got here is 2x minus y equal to minus 1, and it is a line which has a positive slope and whose y-intercept is positive. Okay, so from the option, if we see, this line will corresponds to our T of S, as this line would be exactly what our 2x minus y equal to minus 1. So now let's look at third linear transformation, and its matrix representation is So again, t of 1, 0 is equal to 1 comma minus 1, t of 0, 1 equal to 1 comma 0. So t of x comma y is x plus y comma minus x, or set s is x comma 1 minus x. So we have to find t of x comma 1 minus x, and that is equal to 1 comma minus x. So here it's very simple to identify the line. So t of s is set of all xy such that x is equal to 1 and y is some real number. Now here this might look confusing, but as we know that the first coordinate corresponds to the x-axis and second component corresponding to the y-axis. So even though this is taking the value x, the return value here is x, but it is some variable that is coming from here. So, but actually, in actual it's the y coordinate and this is the x coordinate, and x coordinate value here is 1. So that's why image vector here will look like this. So x is equal to 1. This is a line which is parallel to the y-axis passing through the origin, passing through 1 comma 0. So the graph of this line would look like here. So as we can see, this line is passing through 1 comma 0. So it's the line that is x equal to 1.